All right, so today, oops, that's not what we're doing today. Today, we're going to go over quiz 10.1, and then we're going to do 10.2 correlation and regression, linear regression. And then we're going to do 11.1 goodness of fit test. So we're going to start in on chapter 11. Thursday you have math 10.1 due. Next Tuesday you have 10.2 due and also project lab 10 due. The final is going to be about 30%, 35% on chapters 10 and 11. 12 is actually wrapped into 11 now. It's part of 11. So those 5 sections is going to be 35% of your final because exam 3 is wrapped into the final. So part of it's exam 4. So part of it's exam 4, part of it's the final, but it's all put into that one exam. Does that make any sense? Mm-hmm. Okay. So because of that, roughly like 35% of the final is going to be on what we do today, what we do next, what we do on Thursday, and a little bit of what we do the Tuesday after that, and also part of what we did, the last time we had, like not last class, but the class before that. Yeah.
Are we able to use our half sheets?
Yes.
Like all of them?
Yes. And then the rest of the final will be about 20% on exam 1, 20% on exam 2 material, and 25% on exam 3 material. It's harder because even though I didn't take the hardest problems from there, I just took the average problems from there and some of the easier problems from there, you still have to remember it, and it's a lot. It's been a couple months, right? So it's a lot to remember. Also, the final is worth 26% of your total grade. So 35% of 26%, it's like 8.5% of your entire grade. So it's fairly hefty. It's important. You don't want to tank it. Which leads me to the second slide. Wait, let me finish the first slide, I guess. Focus for 3 more weeks. You've worked hard all semester long. Do not blow it now. All right, stay focused for a couple more weeks. You have your exam, your final is 2 weeks from Thursday. Stay on top of your homework. Stay on top of your in-class labs and quizzes and your tech labs. We're going to go through this part here, I think in about a week, because it's a weighted mean, so it's a really good review for the final, so I'm not going to spend time on it now. We'll do this again. I'll bring this up again in a week. But we'll go through that then. But make sure that you are here next class. So let's do a little bit of review of chapter 10.1. Cook, go ahead.
Review chapter 10.1. Correlation determines if a linear relationship between variables exists. Regression describes the relationship between variables that is positive or negative, linear or nonlinear.
Great. And Lindsay, go ahead.
The purpose of this chapter is to answer these questions statistically. Are 2 or more variables related? 2, if so, what is the strength of the relationship? 3, what type of relationship exists? 4, what kind of predictions can be made from the relationship?
Next, Dennis, good.
A scatter plot is a graph of the order pairs x and y of numbers consisting of the independent variable x and the dependent variable y.
Right. Shashank?
The population correlation coefficient denoted by sigma rho is computed by using all possible pairs of data values x, y taken from the population.
John?
The linear correlation coefficient denoted by R is computed from the sample data and measures the strength and direction of the linear relationship between two quantitative variables. The one explained in this section is called the Pearson product moment correlation coefficient.
PMC. So that's why we're using it. PMC table, which you guys got in the room today. The range of the correlation. So just as a reminder, right, rho, that weird p-looking thing, that's the Greek version. That's the correlation coefficient for the whole population. That's why it's a parameter. Parameters are for the whole population. R, the kind of English version of rho, rho is a Greek letter, R would be the kind of English version of it. That is the sample correlation coefficient. That's what you get from your sample. So we're going to be comparing our R to what we get from the PPMC table instead, our critical value from the PPMC table, to see if it's like a line or not like a line. Remember, we'll talk about that actually right now. Because, April, go ahead.
Correlation. The range of the correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. If there's a strong negative linear relationship between the variables, the value of R will be close to -1.
Right, so -1, totally a perfect line. +1, again, totally a perfect line. And the nice thing is that 1 is really kind of like a line itself, right? It is sort of a line, so it's easy to remember. 0, not a line at all. It's like a circle. Data is just in a circle, totally not a line. Make sense? So this is not a line, so you would not reject H naught. It is a line, you would reject H naught. Okay, so H naught says it's not a line, it's always no. This one says it is a line. So, before we go any further, everybody take 30 seconds on your own with no talking, and then write down which number of these numbers up above best fit each of these pictures. So here's your possible numbers up above for the pictures. Write 4 numbers across the top for those, and then write 3 numbers across the bottom. For the bottom 3, 30 seconds, no talking. Go. Sean, put that. Put Vicky. Take 15 seconds to talk to your neighbors before I randomly pick people.
.5. The difference is like negative I guess that's 0.6.
Second one. The fourth one?
No, that's 0. That's 0.
Oh,
Point 1 over here?
Yeah.
0.8. Yeah.
Oh, yeah.
1. It's 0.6 and
Yeah.
that's 0.1.
Negative 0.6.
Okay, all I know is
Oh, no, the one is the positive.
One, negative 1. Negative 1 is just like negative 0.8.
bottom left
All right, so look at the first one here on the far right. This one here, I'm going to pick a name. Just tell me what this first one is on the far, far side here. Michaela. What's this one? 0. Okay, good. Now we're going to work our way left. So this one here next. Everybody ready? Brandon?
1.
1. Okay, and then we're gonna look at these two here. So the next one over. Haley,
0.8
.8. Why'd you pick .8?
because it's close to a line, but it's not a line.
Does that make sense? It's positive, has a positive slope. It's close to a line, but it's not a line. So it's close to 1, but it's not 1. Make sense? So then what should this one be, you guys think? 0.6. Because we've established it can't be any of these here. It can't be larger than 1 or less than -1. Everybody on board? Okay, now we're going to go with the bottom one down below there. Angel,
Which one, the left one? Or
this one here.
oh, that's gonna be -1.
Uh-huh. Audrey,
-0.8.
-0.8. And the last one. Oh, Charmaine, she left. Zachary,
-0.5.
-0.5. Good, everybody on board? Oh, donuts are really good, you guys should have them. Just saying. All right. Sample coefficient R. Here's the formula for it. And we found it once by using our calculator and our lists. That first semester, my students used to have to find that just using lists. But now, you guys can use stat test, limit to t-test of L1 and L2. Put all your x's in list 1, all your y's in list 2, and that will give you your R. That's your step. This is kind of your step 3. Everybody on board with this? Right? Yeah. X is in list 1, L1, comma L2. Good? Yes? No?
Yes.
Okay. Your first step is this one here. Abdullah, go ahead.
Hypothesis testing. In hypothesis testing, none of the following is true. H
H naught is rho.
rho equals 0. This null hypothesis means that there is no correlation between the X and Y variables in population.
Right, so this means that this is not a line. No line. Okay, keep going.
H1, P does not equal 0.
Rho does not equal 0.
Does not equal 0. This alternative hypothesis means that there is a significant correlation between the variables in the population.
That means it is a line. Make sense?
Yes.
Okay. So, again, rho equals 0, null hypothesis, no line. So if I do not reject the null hypothesis, it's not a line. If I do reject the null hypothesis, then it is a line. Everybody kind of follow that?
Yes.
So, no rejection. If I do not reject, it's not a line. If I do reject, then it is a line. So if I reject H naught, then it is a line. If I do not reject H naught, then it's not a line. Good? I'll put not line. Not reject, not line. Because it's important you guys wrap your heads around that for the later part of today. All right, the second step is this one here. Find your critical value. Use the PPMC table. Remember, now we have an X and a Y. We have two variables. So our degrees of freedom is n minus 2, because it's n minus the number of variables we have. So here I have 10 pairs. What's my degrees of freedom?
8.
8. Great. So that's going to be right here. And my alpha is going to be 0.01. Means I'm going to grab this number right there. How do I show that? How do I draw my picture? It's not like a normal curve. It's a little bit different. It's just a flat line.
Mm-hmm.
Good? Everybody on board with that?
Yes.
So flat line. And remember, these are always two-tailed. So you have your left side, and then you have your right side.
Mhm.
And this is going to be 0.765 and negative 0.765. Okay?
Mhm.
Cool. All right, so do you guys need just another couple of minutes to finish off your problems? Okay, so I'll give you guys 7 more minutes to finish off both